right, so we had our first lesson today, and we worked with our algebra tiles. Algebra tiles are manipulatives that help us see algebra more concretely, and we can move it around and change it. So this is an x squared tile. We won't be using this tile till next semester, and it has a red side. The blue would be for the positive side, red is for the negative side. Okay, then we have our variable tile, and green is the positive side, and red is the negative side. So that represents a variable. In this case, we're working with x. Then we have our constant tile, and it's kind of a goldish yellow color. And we have a positive side, which is the gold color, and then we have a negative side, which is the red color. And that represents our constant. So that represents like a 1, or a negative 1 in this case, or a positive 1 in that case. So what we're doing today is we are learning to model and solve 1- and 2-step equations. So I'm going to have x plus 2 equals 5. That's the equation. And I'm going to use my algebra tiles to model it. So since I'm starting off with my x term, I'm going to start off with my x tile, and it's green because it's positive. And then I'm going to have 2 positive constants, so that's why they're on the gold side. And then we represent the equal sign with a vertical line, so that represents the equal sign. And then I have 5 constants on the other side of the equation, on the right side, so I'm going to pull 5 of those. Okay, so now I have modeled my equation. I have modeled. So now I want to be able to solve for x. And we discussed in class today that we remembered from last year or previous years that in order to solve for x, we have to isolate our x term, which is our green tile here. And since we want this one by itself, we have these 2 positive terms here with it. So in order to remove the 2 positive terms, we have to use inverse operations. So if these is positive terms, then I need to add 2 negative terms. Okay, and when I add 2 negative terms to the left side, I also have to add 2 negative terms to the right side because I need to keep my equation balanced. Okay, so if I add 2 negative to the left side, I have to add 2 negative to the right side. That's to keep my equation balanced. Now, when I have a positive and negative tile paired up, that is called a zero pair. That means 1 minus 1 equals 0, and I can take it off. It equals 0. I have another 0 pair term, so I can take that off. And then I have some more 0 pairs on the right side because I can pair up 1 positive, 1 negative. That can 0 out. And then I have another one where I can pair up and I can 0 out. So now I'm left with my objective. I have 1x, x is over here by itself, and what's remaining are 3 positive tiles. So I have x is equal to 3. Okay, then we need to be able to solve it by writing out the steps. Okay, so we're going to write out the steps that we just modeled. And again, our objective is to get the x term by itself. So I need to remove the positive 2. Now to do that, we use inverse operations. So I'm going to subtract 2 from both sides. And that zeroes out. So I'm going to make a 0 because that zeroes out, and they cancel and go away. So now I have x equals, and then I combine like terms here. So I have 5 minus 2. That's equal to 3. And now I have my solution, x is equal to 3. Now for the next problem. Okay, so now for the next problem, I'm going to model 3x equals 6. So I have 3x terms, so I'm going to have 1, 2, 3, and they're positive, so they're going to be green. And then on the right side, I have 6. So that's going to be 6 units. So that's going to be 6 gold pieces. then now I need to solve for x. So solving for x means I need to know how much each green piece is worth. Okay, so I'm just going to turn them because it'll fit on my board. So I have 1 green piece, 2 green pieces, 3 green pieces. And I want to know how much 1 is. So that means I need to distribute my 6 pieces to each one of those evenly. So I have 1 that can go here, 1 that can go to the second one, 1 that can go to the third one, and then I'm trying to divide those up evenly between the green pieces. So now I have the 3 x's, and each one can have 2. So if I'm solving for 1x, then I can move these out of the way, and I know that 1x is equal to 2. So when I'm solving and writing out the steps, I have 3 times x, and the inverse operation for that one is to divide. So we're going to divide by 3. And what we do on one side, we do on the other. And when I do 3 divided by 3, that equals a 1. So if I cross through it, because they cancel each other out, I'm going to make that into a 1, because 3 divided by 3 equals 1. And I'm left with x on the left side. And then I divide 6 divided by 3, and I get 2 on the right side. So I did get that x is equal to 2. Now we're going to kick it up a notch with a 2-step equation. Okay, now we have a 2-step equation, 2x minus 1 equals 7. So I'm going to model that with my tiles. I have 2 x's, so I'm going to have 2 green tiles, 2 green rectangles. I have a -1 constant, so I'm going to have a red -1 there. And then on the other side of the equation, I have 7 positive constants, so I'm going to have 7 positive constants there. And then again, my goal is to get the x's by themselves. So if the x's need to be by themselves, then I have this -1 constant that I need to remove. And we remove it by inverse operation. So since it's a -1, I need to add a +1 to it. And whatever I do on one side, I have to do on the other side, so I have to add a +1 here. If I come back, I do have a 0 pair, because a red one and a gold one together add up to 0. That is a 0 pair, and I can remove that. And I don't have any 0 pairs here. So I have 1, 2, 3, 4, 5, 6, 7, 8 units on the right side. Now I have the 2 x's left, so I need to divide up those 8 unit tiles into the 2 x tiles. So now I can have 1 here, 1 there, 1 can go here, 1 can go there, this one can go here, that one can go to the bottom one, this one can go to the top, this one can go to the bottom. So I can see that I can divide those 8 tiles evenly into 4 and 4 to 2 groups. I need 2 groups. So then I know that my x is equal to 4, because I can remove those because I just need 1x, not 2. So 1x is equal to 4. Now when we work on solving the equation, we removed the -1 first by doing the inverse operation, which is adding 1. So I need to add 1 to both sides. -1 plus 1 makes that 0 pair, and it zeroes out and goes away. So I'm left with 2x on the left side, and 7 plus 1 is 8 on the right side. And then I want to divide by 2 on both sides. 2 divided by 2 equals 1. So I'm going to make that into a 1. And that's going to be x equals, and then we have 8 divided by 2 is 4. So then I have my equation solved. X is equal to 4. Okay, so that concludes our modeling and solving. And you had an assignment to complete today that did both modeling and solving. And that is what you will complete for today's assignment.